Welcome back. In this video, we're going to go over section 7.2, which is about factoring a specific kind of trinomial. In the last section, we saw all the basics of factoring, common factors, and all that stuff. So it's pretty long. This section will be shorter and is more specific. So we're looking specifically at factoring trinomials, so polynomials that have three terms, and they have the form x squared plus bx plus c. So the variable here, it's x, is squared. And we have a number times x and then a constant term, which is that plus c. So they'll look like that. We may use other letters besides x, but that's the basic format for these. So as you recall from our earlier work, there's a relationship between multiplying and factoring. When you multiply, for example, x plus 7 times x minus 4, you'll get x squared plus 3x minus 28. And we want to see how to reverse that process. And we're going to do it by looking at 4 different multiplication problems and see if we can detect a pattern and then use that pattern to help us undo that multiplication, that is to do the factoring. So let's have a look. For this one, I've used 5 and 3 for the numbers, just to keep that piece of it uniform. So we have x plus 5 times x plus 3, x minus 5 times x minus 3. So all I've done is I've just messed around with the patterns of pluses and minuses to give all 4 different possibilities from both plus, both minus, plus minus, minus plus. So let's multiply all those out real quick and see what we get. So for the first one, we'll have, I'm going to use FOIL. A lot of times people like FOIL for this, so let's just do that. First here, x times x is x squared. Outers will give us 3x, inners 5x, and then last 5 times 3, 15. Adding together the pieces, we'll have x squared, 8x, and 15. So let's go ahead and do the others. All right, so that's how those look. So let's see if we can figure out a pattern for this. So all of them are going to begin with x squared. We're multiplying x times x. So they all have x squared. And notice that they're all in the back end with either 15 or negative 15. And so we need to figure out if we're going to reverse this process, how do we get from the bottom line in black back up to what we had in purple? So here 3 times 5 gives 15, and so that's no surprise. It's the product of the lasts. That is, if you're using FOIL, you can think of this, those second numbers 5 and 3 as the last. So 5 times 3, 15, which is why we're getting either 15 or negative 15. And we know from beginning algebra or arithmetic, when you multiply together 2 positive numbers, you get a positive answer. When you multiply 2 negative numbers together, also you get a positive answer. So here we had positive 5 times positive 3, which is 15, or negative 5 times negative 3, also positive 15. So when those two signs were the same, either both positive or both negative, we had a positive 15. When they were different, we had positive 5 and negative 3, or negative 5 and positive 3, then a positive times a negative is negative, right? So we'd have a negative 15. So taking a look at that last sign can tell you, if you're trying to factor, if the two numbers that you're trying to find to fill in the blanks there, if they are the same sign or different signs. For the middle part, that is the number next to the x, here it's 8x, minus 8x, 2x, negative 2x. It's the sum, right? When you're doing FOIL, you're adding together the outers and inners. Here, when the two signs were the same, both positive, we had plus 3x plus 5x, that gave 8x. When they were negative, negative 3x plus negative 5x, negative 8x. The last sign, being plus, tells us the two numbers are the same sign, either both positive or both negative. And if they are, then the first sign, that plus or that minus, tells us whether we're looking for two positive or two negative numbers. When we're multiplying together two numbers of opposite signs, getting a negative constant term, then we still have 5 plus 3, or negative 5 and positive 3, or positive, I've run out of all the possibilities. I've lost track, sorry. 5 and -3, -5, +3. All right, so 5 plus -3 will be +2. -5, +3 will be -2. In the first case, we had -3x plus 5x. 5x, 5 is, excuse me, 5 is more positive than -3 is negative, which is why their sum is positive. For the last one, we had -5 and +3. 3x and -5x, those two will add up to -2x. All right, so we can see that by looking at the different constant term or the coefficient of x, that gives us some clue about the numbers that we're looking for when we're trying to factor. So let's try some examples. For the next one, or the first one, we have x squared plus 6x plus 8. All right, so what we want to do now, we've got x squared plus 6x plus 8, and we want to recover a product of binomials that will equal that. So thinking about how FOIL has to work, I know that the firsts are going to be x's. X times x will give us x squared. And then we need to figure out what the other stuff has to be. This is the hard part. Notice that the constant term is positive. And we know that a negative times a negative is positive, and a positive times a positive is positive. So these two things that we need to find out have to be the same sign. And that's what this plus sign tells me. Since those are positive, this is either going to be both plus or it's going to be both minus. We just have to decide which. How you know which is by taking a look at the coefficient of x, and here it's positive. So these are the same sign and both positive. Okay, and now we need all right, sorry about that. Zoom crashed on me again. All right, so here, thinking about the lasts for FOIL, they have to multiply to be 8. The outers and inners have to add up to 6. Two numbers that multiply to 8 and add up to 6 will be 4 and 2. So we'll have x plus 4 times x plus 2. And that's it. Of course, multiplication is commutative. So if you have x plus 2 times x plus 4, that's going to be the same thing. All right, let's try this again. Here we have y squared plus 11y plus 24. This time it's y's, but that's okay. By the way, if you're doing this on like online homework, My Open Math or some other, then make sure that you type in the right letter. It's a shame to get it wrong just because you used an X instead of a Y when you had the right kind of idea. So make sure you're using the right letter here. All right, so we have y times y will give us y squared. And then in the back, we have a plus. So once again, that tells me that it'll either be both negatives or both positives. And this time, the number in front of the y is positive, so I know it's both pluses. Now we're looking for two numbers that multiply to 24. I like to call these numbers P and Q. Some people call them A and C or others. So the two numbers we're looking for, they have to multiply to be 24 and add up to be 11. If there's a hard part to this process, it's right there, figuring out what those two numbers have to be. And it's also kind of the fun part. They have to be 3 and 8. So we'll have y plus 3 times y plus 8. Okay, here's one for you to try. We're going to factor t squared plus 14t plus 24. So take a second, pause the video, and try this one yourself. Okay, so we've got t squareds, so there'll be a t and a t in the front. We're looking for two numbers. I'm going to call them P and Q so that their product is 24 and their sum is going to be 14. They're the same sign and both positive. Okay, two numbers that multiply to 24 and add to 14 would be 2 and 12. Okay, so this one's going to be a little different. Notice that the signs aren't both plus this time. So that's good. We get a little variety. We're sticking with y's. This time, The plus in the back tells me that the two numbers that we are looking for are going to be the same sign, but now they're both negative. So we have y minuses. Okay, we're looking for two numbers that multiply to 28 and add to 11. We'll call them P and Q. P times Q is 28. P plus Q is negative 11. So that'll be negative 4 and negative 7. Y minus 4 times y minus 7. Once again, remember that anytime you're multiplying or factoring, anytime that you're factoring, you can multiply to double check your work. Okay, we have just a few more examples. Okay, this one we've got some w's. W squared minus 9w plus 18. So we have a pair of parentheses. W's this time, same sign. We've got a plus in the back so that they're going to be the same sign. And in front of the 9, we have a negative, so it will be both negative. We're looking for two numbers that have to multiply to be 18, and they have to add up to be negative 9. Okay, so are there two numbers that multiply to 18 and add up to be negative 9? All right, so two numbers that are the same sign, both negative. Will be 3 and 6. W minus 3, W minus 6. All right, let's try the next one. Okay, we have x squared plus 4x minus 12. This time the negative sign, there's a negative sign in the back instead of a plus sign. So this time we're going to have a positive and a negative. The two numbers we're looking for will be different in sign. They need to multiply to be negative 12, and they need to add up to be positive 4. So two numbers that differ in sign multiply to be negative 12 would be 3 and 4, 1 and 12, 2 and 6. 2 and 6 sound good, but we need to make the patterns of signs work out so that their sum is positive. 6 plus negative 2 would give us 4. Negative 6 plus positive 2 would give us negative 4. So because the coefficient of x is positive, we know that the number with the bigger absolute value is the positive one. So it'll be x plus 6 and x minus 2. All right, for this one, both signs are negative. So that'll be interesting. We'll have x's again. This time we're looking for numbers that multiply to be negative 12. And they have to add up to be negative 4. This time the coefficient of x is negative. So the add-in with the larger absolute value is going to be the negative 1. So we should have negative 6 and positive 2. And once again, double check by multiplying if you like, and you should get that that works out. Okay, well, let's see. We've got r squared minus 3r minus 40. So this time we have r's. Okay, this time we're looking for two numbers that are different in sign. So 1 plus and 1 minus. That last sign being negative is what tells me that the two signs are different. 1 plus, 1 minus. So we're looking for two numbers that multiply to be 40 or negative 40. And so that sounds like 8 and 5, 10 and 4. 8 and 5 are ones that kind of differ by 3. I mean, we'll have to play around with the pluses and minus to get that worked out, but 8 and 5 differ by 3. 10 and 4 differ by 6. And so we're going to want 8 and 5. So P plus Q has to add up to negative 3. So the sum being negative tells us that the negative add-end is the one with larger absolute value. So we should have negative 8 and positive 5. Okay, double check by multiplying. R squared minus 8r plus 5r minus 40. Yeah, that would work out. Negative 8 plus 5 is negative 3. Okay, let's try this next one next. We're back to both pluses this time. So this time we have x's in the front. The last term being positive is going to tell us that the two signs are the same. The plus in front of the 4 tells us that they're both pluses. So this time we're looking for two numbers that are both positive. They have to multiply to 18 and add to 4. Well, 18, numbers that multiply to 18 are going to be 3 times 6, 2 times 9, 1 times 18. And that's it, right? This one doesn't factor using whole numbers. And so when that happens, we can write out prime. As you know, with numbers, when you're factoring numbers, lots of times you can factor, right? 27 is 3 times 9. 26 is 2 times 13. But then there's some numbers that you can't factor like that, right? 19 is what times what? Is 19 times 1, right? You can't really do much more with it than that, right? I guess if you want to be fancy, you could say negative 19 and negative 1, but that's not helpful too much, right? 19 is a prime number, just like 7 and 11 and 13 are also prime numbers. You can't factor them in any kind of interesting way, so we say prime. When a polynomial has that property, we use the same word and say, okay, well, it's prime polynomial. We were not able to factor it. Okay, so we've got most of it. How can this be harder than what we've seen so far? We put more variables in there, not just changing our x into a y, but have x's and y's in the same problem, let's say, or maybe writing the terms out of order. Both of these are kind of minor complications, but we'll see how to do those. Okay. So here we're going to factor 9x plus x squared plus 18. So what I would do first is just rewrite this in kind of the format that we're used to, where it's in descending order by degree. We have x squared plus 9x plus 18. Now that's more what I'm used to. So x's, so we'll get x squared, that gives us the x's. In front of the 18 is a plus, so we're looking for two numbers that are the same sign. In front of the 9 is a plus, so that tells me that those two numbers are both positive. Numbers that multiply to 18 and add to 9 would be 6 and 3. Okay, and that does it. Just the only new thing there was having to rewrite it so that the terms were in order. All right, this one, we've got two variables, x squared plus 12xy plus 36y squared. What's new about this one is that there are two variables, x's and y's, within the same problem. But the mechanics of how you do this is really similar to what we've seen already. It leads off with x squareds, so our firsts will be x's. And then we're looking here for numbers that multiply to be positive 36. So they're the same sign, both positive. We need numbers that multiply to 36 and add to 12. That sounds like 6 and 6. Now, if we quit right here, we'd have, if we multiply it out, x squared, 12x plus 36. So we just need to incorporate the y. And how you do that is notice that for the lasts, we need 36y squared. So let's just insert a y after the 6. That will make it so that our y squareds will have 36y squared. And also notice that it makes it so that the outer inner terms will end up with 6xy for both. And so we'll end up with the 12xy as we needed. Okay, and that will do it. All right, here's one for you to try. I've left the work up there for the preceding example, so you can use that as a model if you need. Take a minute, pause the video, try this one with the U and the V in it, and then restart the video and see how you did. Okay, so for this one, it starts off with U's, so we'll have U in the front of both binomials. And then we're looking for numbers that multiply to 28 and add to 11. That sounds like 7 and 4. And we need a v in the back. So we'll have u plus 7v, u plus 4v. Again, if you have u plus 4v as the first binomial, it's fine. It doesn't matter. Multiplication is commutative. Okay, here's one more to try. This time we're going to have some negativeness in it, but that's okay. Once again, pause the video, try this one, and then restart the video and see how you did. So we'll have A's in the front, and I know I'm going to end up with B's in the back. The plus sign in front of the 10 tells us that we're looking for numbers that are the same sign. The negative tells us that those two numbers are negative. And then we need numbers that multiply to 10 and add to 11. So that sounds like negative 10 and negative 1. I'll put the 1 in there just for emphasis. We'll have A minus 10B and A minus B. And that will do it. Okay, we are almost done with this, I think. One more. This time both the signs are negative. We'll have x's in the front and y's in the back. We're looking for two numbers that have different signs. So one's plus and one's minus. We're looking for numbers that multiply to be negative 10 and add to be negative 7. So how do you multiply and get 10 would be 2 and 5. That sounds like it's a good way of getting 7. It would have been 2 and 5 or 1 and 10. So it's got to be 2 and 5. We need them to add up to negative 7, though. So 2 and 5. Okay, so we need the two numbers to multiply to negative 10, but they have to add up to be negative 7. But notice that they're supposed to be different in sign. So let's think about that a little more. All right, so that's a bit of the frustrating part about doing factoring is that sometimes it just doesn't factor, right? So don't see how we can get numbers that multiply to negative 10 and add to negative 7. So for this one, it looks like we've got a prime polynomial. So that's kind of unsatisfying. So let's have one more example. And well, let's see if we can make this so that it does factor. How can you do that? Well, this would have factored. Do you think it would have factored if we would have had plus 7xy minus 10y squared? All right, so here we need numbers that multiply to negative 10, but add up to positive 7. So that's still not going to help, right? Because we need numbers that multiply to negative 10 and add up to be positive 7. So we're kind of in the same situation as we were in the previous example. So if we need the numbers to be different in sign, then let's make them like 5 and negative 2. Okay, just to make up another example. So if we had positive 5 and negative 2, that would have been a 3xy. Okay, that's one that can factor. So let's do that. All right, so now we're looking for two numbers that multiply to be negative 10 and add up to be positive 3. So two numbers that multiply to negative 10 and add up to positive 3 would be negative 5 and positive 2. So we'll have x in the front, y's in the back, 1 plus, 1 minus. It'll be negative 5y and plus 2. So x plus 2y, x minus 5y. All right, so just so that we're clear, the original problem or original polynomial didn't factor, so I made up an additional example where it would factor, just so that we could finish on a nice note. All right, that takes us to the end of section 7.2. We saw this kind of specific case of how to factor these certain type of trinomials. In the next section, we'll kind of expand on this. You'll notice that all the examples that we had in this section, the coefficient of x squared was a 1. And in the next section, we remove that restriction and say, well, what if it was something other than 1? All right, that takes us to the end of this section. Let me know if you have any questions, and have a great day.